Welcome to Broadcasting Common Ground, the Deep Foundation Institute's podcast channel. In this series, Interview with a Survivor, our hosts, Lucky and Tim, will be discussing near misses, problem projects, and resolutions. This episode features discussion with Tom Richards, former Chief Engineer of Nicholson Construction Company. Tom talks about a joint venture to install micropiles for a bridge with problems including an unexpected aquifer and difficulties implementing new design details. Proudly brought to you by our series sponsor, Peer Research, and today's episode sponsor, Ishbeck USA.
Welcome to DFI's podcast, Broadcasting Common Ground. I'm Tim Siegel, and I'm glad to be here with my co-host, Lucky Nagarajan. Hi, Lucky.
Hey, Tim. Great to be here.
Hey, it's great to have you. It's our sixth and final episode in our series, Interview with a Survivor. It has been a great run here. Our guests have been remarkable. Shout outs go to Billy Camp, Cord Wisman, Greg Ryder, Cassandra Wetzel, David Wilshaw, and our prototype, Sebastian Lobo Guerrero.
Our final guest on this go around is Tom Richards. We all know Tom. We have seen him multiple times, and he is a legendary icon of the industry. And Tim, you describe Tom as mild-mannered and also methodical.
That's right, Lucky. I've known Tom a good many years. It's a lot longer than when I first started thinking about it, they counted up. But he has always been very thoughtful. And I think everybody that's been around Tom knows he's truly an engineer's engineer. He doesn't flaunt it, and he doesn't go around trying to impress everybody with his knowledge. But there are truly few in our industry that can compare to Tom. So without any more delay, let's add Tom on our show here.
Hi, Tom. It's so good to see you and have you on this podcast.
It's great to be here, and I'm honored to be invited. I think with all the accolades that have been thrown my way, I'd like to tell a Tim Siegel story of the first time I met him. So my recollection is we were both speaking in St. Louis at a DFI Lateral Loads Committee seminar. And Tim probably talked about drag loads. It's a big topic he likes. And I was really impressed with his talk. So, we got together for dinner, and I recruited him really hard at dinner. I was really trying to get him to jump from a competitor to Nicholson. And after some wine and water, I had to go to the bathroom, and I get back and Tim's already paid the bill. So I got a recruiting meal paid for by the guy I was recruiting.
I remember that, Tom. That was enjoyable dinner. It was my pleasure.
Tim is super fast in that. I've noticed that the first time we met after COVID, if you remember, Tim.
I do.
We remember meeting Cord for the first time as well, and then he was so quick in paying the bill.
Well, that was my pleasure as well.
So, Tom, I know you live in Western Pennsylvania. Is that where you grew up?
Yeah, I grew up in the northern suburbs of Pittsburgh in the same county, right at the edge of the county. I met my wife, Carrie, at college at the University of Pittsburgh. And then after we got married, I crossed two rivers, which is pretty unheard of in Pittsburgh, and moved from the northern suburbs to the southern suburbs. And we live in my wife, Carrie's family. It's her great-grandfather's farmhouse built in the late 1800s.
Wow, Tom, that's pretty cool. And when we started getting ready for the show, you had mentioned that you've got a household of engineers. Who does what in your family?
So Carrie is a chemical engineer by training, and she started out in tech service and did that, but most of her career was on the business side. And honestly, that's how we retired early. Our older son, Russell, he's a mechanical engineer, and he works for the nuclear Navy, and he's currently at the shipyards in Norfolk, Virginia. And my younger son, Wesley, is an electrical engineer, and he works in Pittsburgh probably a block from his house apartment, and he does computer chip design. And it used to be Ethernet communication, and now it's something else.
That's amazing. Truly, family of engineers. That's amazing how you can see your younger son and older son have picked up the different types of engineering, but they do a very outstanding, niche job. That's amazing. So, Tom, can you give us a thumbnail sketch of your professional history? Where did you attend university, and when did you join Nicholson, and what was your journey like?
So I went to the University of Pittsburgh, as I mentioned, for undergraduate. And then as I worked, I had taken some part-time graduate classes. I started to work for GAI consultants, and I knew that, I was going to do that for 3 years and then think about something else. And I ended up working there for 3.5 years. And then in 1988, joined Nicholson after meeting Donald Bruce and Pete Nicholson at industry events, local ASCE meetings, and a case histories conference in St. Louis.
Well, you
Then
had, go ahead.
It looks like rest is history, right? Started with Nicholson, and everyone knows Tom Richards.
Okay, well, most of what I did at Nicholson was technical stuff. It was all kinds of different techniques, but always looking at the technical aspects of it.
Tom, you had alluded to the fact that Carrie's work as on the business side of chemical engineering had allowed you to retire early. But I've also kind of heard the grapevine, and maybe from you, that this was a master plan of you and Carrie's, that you were planning on retiring early and taking advantage of that.
Yeah, it was always a goal so that we could spend time, primarily snow skiing was our objective, but also traveling before we got too old and tired to ski.
Well, so what does a day look like for Tom? Now that you're, I'll say semi-retired, give us an idea of what it looks like to be Tom Richards.
So in the winter here at Park City, we rent a house, and then we leave the house at 10 minutes after 8 so that we can get into the parking lot. And we ski till about lunchtime, or when our legs finally tell us it's time to take a break, and come back and have a typical meal is soprasada and some good cheese, and maybe a little wine, good bread. And then maybe a little bit later, dabble with a little bit of work. Then shovel snow most days, got to shovel some snow. In the summertime, we water ski. And so about 4 days a week, we get up and we're on the boat at 8 a.m. While the water's still flat. We ski on the Monongahela River.
Wow.
And I currently do some consulting to Nicholson, very part-time. And mostly it's the engineers emailing me or calling me with technical questions.
That's amazing. That's dream come true for me as well. Thinking about, I've always, after I finished retiring, I always wanted to work in national parks of United States of America.
I love it.
I've always wanted to do that. Maybe one day I'm going to call you for that.
You can do it. You can do it, Lucky. Tom as your inspiration.
Yes, definitely. And he eats everything that I love. Bread, cheese. Amazing. So, Tom, as you know, we chose the title of this podcast series as Interview with a Survivor. We really want to learn firsthand from people who have lived highs and lows on projects. Highs, a lot of people will speak about, but lows, not many people speak about. So thank you for your willingness to share what you may consider as low.
Oh, you're welcome. It's an older story, but I think you'll find it interesting.
Well, let's move on to the story, Tom. Would you mind setting the stage for our listeners?
So this was a micropile project for a bridge in a coastal deposition environment. So sands and some clays and silts. And the bridge crossed a creek valley, and that creek eventually outlet it into a saline body of water, not too far away from the bridge crossing. The piles were designed by us, except for a seismic casing, which was defined by the owner. So they had done L-pile type analysis. They used Florida pier analysis, and come up with the size casing they wanted for a certain depth. And then we had to develop the bond zone below there. And this casing was 12 3/4 inch OD, which was pretty big for the mid 2000s. The owner provided geotechnical information primarily as stick drawings, with just the CLML beside the borings in the plans. But you could also go and look at the detailed boring logs at the regional office. And somehow there were some CPT reports out there that pertain to the project, but they weren't officially available or listed in the contract documents. So in the zone that we're going to talk about, the founding soils were fine silty sands with some running sands called out on the borings. And on some of the lower elevation borings, there was drilling mud return with the casing stick up of a couple feet. So we knew that there was some excess water pressure down there. There were also some piles that were founded in clay, but that's not really what we're going to talk about today. So we were bidding this project when our backlog was low, and we all felt that we needed the work. There's kind of like this pressure. So the winning GC, he gets the work, and he's working with a competitor who was a buddy of his from college. So his price was really close to ours. So this competitor then offered to JV with us. And I don't know if that was instigated by having some trouble getting a qualifications approval. It really wasn't warranted. They were a credible competitor. And so our managers decided that the competitor's price was remarkably close to ours, or close enough to ours. So we did a JV. And we installed some test piles and reactions down near the creek. And one of our old field engineers, Pablo, took me down and showed me water seeping up between the grout body and the soil. I think this was after our first failed test. And I knew this wasn't a good sign.
Tom, you mentioned during the show prep that one aspect of deciding to pursue this project was that your firm, Nicholson, needed the work. That phrase means something specific in the world of contracting, right? Can you explain this to our listeners a little bit?
Well, any contractor needs work to keep both the shop and permanent employees busy, and to cover the depreciation on equipment. And if you don't cover those things, you don't keep the employees busy, then you start losing the competitors. So you can kind of get this feeling around the office that we need the work, and we all feel pressure to get some work. Even if you really try to be objective, you still feel it. And so, you think more optimistically, I'd say. And we just can't wait around for the next T&M emergency job like Mandalay Bay.
That's very true. I think that's very true. It's just that, a lot of employees were able to recognize that and try to bring in work, right? This is very common in the construction industry, I'm sure. So it's time for us to take a very brief break and recognize the sponsor of this episode. So we have Mark Mastrantuno, Geotechnical Division Manager for ISHPEC USA. Mark has been in the industry for just over 10 years, specializing in hollow bar anchors. This takes me back to Nucor Skyline, Mark. He has been supporting contractors and engineers all over the country with ishbek materials. His favorite is problem solving and finding innovative solutions on projects. Other engineering adventures include being hands-on in designing and installation for the clients. He takes great pleasure in final completion of the projects and feels proud to be part of the design. He's married with a son and a daughter on the way. Congratulations, Mark. He's a die-hard motocross rider over 30 years. I don't think I've ever met a motocross rider before. Among other things you enjoy to do. So Ishbek USA is the manufacturer and supplier of the original Titan hollow bore micropile system in the United States. Ishbek is the North American subsidiary of the German Frieder. Ishbek, well known throughout the construction industry as innovators in formwork, trench lining, and geotechnical solutions. Incorporated in 2009 with support from Friedrich, Ishbek USA is able to offer original, high-quality geotechnical solutions that are manufactured in the USA. Welcome, Mark. Welcome to the show.
Thank you. It's good afternoon, and I'm happy to be here. It's good to see everyone, and I appreciate the opportunity for allowing us to do this. So it was good to see you, Tom. I know you're retired, but you don't miss a show. So I see you at a lot of events, and it's always good to see you. So got a few questions for you. They're pretty easy, so no pressure, but just with your past, you've been doing this a long time. Over, let's say, the last 10 years or so, what was a major accomplishment that you have that you're proud of and you've achieved?
Well, I've been retired for three or four now. So really planning for that retirement was a big thing, and the accomplishment was organizing the information I had, reports in a systematic file structure, and sharing that with the engineers at Nicholson and with the industry to some extent.
So going off the previous question, let's go back a little further in your career. If someone asked you your most favorite or memorable project, does any of them stand out to you over the course of your career?
Yeah, so I mentioned Mandalay Bay already. Yep. It's in Vegas. It was a T&M emergency micropile job. I present that topic during the DFI traveling lecture stops, some of which are virtual. So check out the DFI website and you can maybe catch one of these Mandalay Bay stories somewhere else. Sure. I also love dam anchor jobs. So you told me only one, but I do love dam anchor jobs. They're just so high tech.
Mm-hmm. Well, in your time in the industry, do you believe that geotechnical design and construction has advanced the technologies, the means and methods, the design practices, and everything to keep up with the ever-changing challenges that occur in this industry?
Well, I'm honestly shocked at some of the amazing things that were done in the past. Mm-hmm. We looked at a building in Detroit that they wanted to put in a new basement, kind of re-excavate a basement of a building in Detroit. And we couldn't figure out how they ever made an excavation that deep in that soft ground. And you see pictures of deep excavations in New York City before there was jet route cutoffs, and it was all about dewatering then, I guess. But just some of the things that were accomplished before we had the new techniques. Contractors have certainly brought forth new technologies and means and methods, and they make solving some things more certain or reduce the risk or make it less costly than if we'd still had to do it the old way. Mm-hmm. You mentioned engineers, we have more analytic tools. I'd say the biggest ones are the earth retention programs, where there's springs on all the sides. You just don't have to do traditional, pins at struts type calculations. It's very rigorous.
So coming off of that question a little bit, what kind of technology that do you wish you would have had at the beginning of your career that you have access to now that would have maybe made your life a little easier back then?
Well, this is a very specific thought, but it involves drilling with polymers or drilling with grout.
Mhm.
We dabbled with polymers off and on, but I think it's kind of late in my career. In the 90s, we didn't do a whole lot with polymers. And the drilling with grout's amazing. We learned it from really working with hollow bars, is how much better bond you can get because of the good support from drilling with grout.
Right.
Which I know Ishibek's glad to hear me say.
You're right. Right. So finally, what advice would you give for an engineer that's, up and coming or aspiring engineer, maybe even the advice you gave your kids, while they were in engineering school? And
well, when I got an award from DFI and made a talk, and I gave the charge to the young engineers, and that's kind of in my head still. The first thing is find something that you really love, and commit to it as a career and profession, not just a job. Find somebody to be a mentor, and that mentor could be drillers, pile drivers. My mentor was a teamster, taught me the most about dam anchor stressing, or anchor stressing in general. Then get involved with some professional group like DFI. Join a committee within that organization, and just hang out and listen to people telling stories. Stories I just told about the excavations in Detroit or whatever. And come to the meetings and network with people. And that includes networking in the bar. And the last thing is, don't be afraid to talk to us old guys, but realize we might have a hard time hearing you in a crowded, noisy environment.
Thank you, Mark.
Yep, you're welcome.
Really great. It was great having you.
It was a pleasure. Thanks.
Before the break, we were talking with Tom Richards about a DOT project that involved larger than normal diameter micropiles for a bridge in a coastal area. The geotechnical characterization was in the form of borings provided in the bid plans. We learned that it was a joint venture, and after award and during production installation, one of Nicholson's field engineers, Pablo, observed substantial water channels from the tops of micropiles and reported this to Tom. Tom, before we dig in deeper, this sounds so familiar, where there's a field person who is in tune with the project, in this case, Pablo. Does that kind of also resonate with you? Isn't it remarkable sometimes how you have a field person that is watching things, and they're the ones to first catch this kind of stuff?
Yeah, absolutely. Pablo was a remarkable guy. I think at the time of this job, he was at least in his mid-60s, and he'd been around this stuff forever. But I do find it is true, when something's going wrong, it's good to talk to the drillers, pile drivers, just see what they're seeing.
Absolutely. I mean, it seems you and I have a very similar background. We'll wonder what's going wrong on a site. We'll get a call out there. We'll go out there and we'll find out. The best thing to do is to talk to everybody. And you more than likely you're going to find one person that can tell you a story of what they've seen, and it's going to be valuable. Anyway, I just thought it was interesting. You brought this up and remembered his name from 10 years or 15 years ago.
Oh, but I worked with them for 20 years,
Sure.
So, and you used the word substantial. This was just like a trickle of water coming out, but it was weird, very weird to be at the interface between the grout and the soil. So it wasn't like it was obvious. Everybody saw it. Pablo caught it. If you just walked by, you wouldn't.
They wouldn't catch it. Well, very good. Well, Tom, after Pablo shows you this perhaps insignificant trickle and says, and points it out to you, what happened next?
Well, so I think that was after the first load test failure. We tried another load test, and we realized from that seepage that there was more artesian pressure than we kind of thought we were fighting against. And so we put in an open standpipe piezometer and extended the PVC about 15 to 20 feet in the air, built this big stair to get up there and read it. And, found that the number was maybe 17 feet of artesian pressure compared to the couple feet we thought we were dealing with from the overflowing casing or the overflowing drilling mud in the exploration. So you can imagine that the borehole stability, as you're drilling a hole, isn't good with this water pressure trying to push everything back up the hole. And think about digging a hole at the beach below the saturation line, the hole collapses. And this is true even when you have casing in the hole, because there's still an area of disturbance outside the casing. And although it's not well defined in the micropile or drilled shaft literature, the bond stresses or skin friction you achieve is very related to the borehole stability that was provided in installing it. So the next thing we do is we try an Ishabeck. So I'm sure Mark loves hearing this. We try an Ishabeck hollow bar drilled pile. We drill it with grout to enhance borehole stability. So by having that grout in there that has a density, it might have been a 1.5 density, 1.5 specific gravity, even as high as 1.8 is the drilling grout. That overcomes that water pressure much more effectively than the column of water inside your pipe. And that pile, we put a big, we did put like a 12-inch bit on the thing, but the pile tested great. But in the end, the owner said, no, we can't install a pile using that methodology. And that there was some combination of basically not meeting the spec, because we were open holing with grout as a support fluid, and the spec said you had to drill with casing. And that the Ishabeck, which was the only one on the market at the time, would have required a variance to Buy America or Buy American, prove that it's really needed for this application. And the answer was just no. So in the end, we made the piles longer and put in more test piles, and I spent more time drilling and more materials on all the piles.
Tom, how is it important to the story that you just shared that this was a joint venture? Did it make any difference?
For me personally, the joint venture required that anytime I wanted to do something different, I had to convince twice as many people on things that I wanted to change. And it sounded fun at first to work in joint venture with these guys, but eventually that just extra layers of approval, even before we decided what to do, was frustrating for me. It also meant that we had a gang of people at meetings. So we'd go to these meetings after test pile failures. You usually have a meeting with the owner and say what you're going to do next. And we'd have, 10 people go to this meeting, and the meetings just kept getting bigger and bigger. Now, on a good side, it meant that we shared the risks. So all this bleeding of cash that was happening wasn't all on us.
Well, that's a very good way of putting it. The advantages and the disadvantages of being in a joint venture on a project like that. So, Tom, we understand that your team determined a successful path forward, but not without incurring cost, which you were just talking about. Were you able to recover those costs from the DOT at all?
Well, we recovered a little bit. So we submitted a differing site condition, and in the process of this, find that the owner had standpipe piezometers that they didn't share at all. And those standpipe piezometers showed similar levels of artesian head like we found. But the DOT just basically said no. And so we take the next steps and get some lawyers involved. Things get drug out until the full bridge project is closed out, and there's still this claim out there. And in the end, we settled for like 10 cents on the dollar. So, and there's not that much fat in the numbers that you turn in, that it means that basically the job lost money. It wasn't about covering overhead or keeping equipment rented. It was a pure net room, red numbers all over the balance sheet, pure loss. Although not part of the rejection, the CPD data did have some hints of this information. If you really dug through all the thousands of pages of the CPT report, which was really just paper copy, no electronic files, you could take the dissipation tests and find high levels. But that really wasn't any part of their rejection. They just said, no, sorry, you had the boring information. And the CPT data wasn't really officially available.
In prep for this episode, Tom, I shared with you my frustration on the whole differing site issue. It seems like an insurmountable climb, and it really seems a very rational reason to have it, right? I mean, we know that geotechnical conditions vary. We know that there's unexpected behavior. We know that risk, that there's no successful contractor wants to take on 100% of risk when he can't control that risk. But yet here we are. I mean, it is very, very difficult to successfully fight a differing site condition claim. Tell me what your thoughts are as one that's worked in this industry for, 30 plus years.
Well, in those 30 years, I think I've only been involved with 3 differing site condition claims. So it's not like it's a routine thing. And what I've always found is that everybody gets very defensive and unfair. On this one, they withheld information with those standpipe piezometers. On another one, but it had obstructions, the owner said, there's a boulder in this boring at this elevation, there's a boulder at this boring at this elevation, there's a boulder at this boring at this elevation. If you add them all together, you should have expected continuous boulders. And it's just, that's so extreme and unfair that you end up giving up on that type of situation, because paying lawyers is not how we're going to get this resolved or effectively. Now there's a reason that the clause is in there. We can't all think like all these boulders meant we should have expected continuous boulders, or the prices will be higher, and well, we won't get the work, but the prices will be higher. So the purpose of the clause is so that there's a shared risk. You make a reasonable interpretation on what's provided, and if it's more than that, then you talk about how to economically account for it.
No, go, Tom. That's a good point. So, and maybe this is for some of our listeners, is to understand that the differing site condition really on the front end is a protection for the owner, because that way it allows him to get much more competitive bids, because folks, especially competitive bids against from very established and reputable firms, because it's saying, hey, look, you don't build into your bid a lot of extra money to cover risk. We want you to be competitive. And then it seems like once a firm or a specialty contractor gets the project, that's all forgotten. It's like, oh, no, we put that in there so you had 100% of the risk, and we're never going to let you have a different site condition. That, I don't know, it just, I'm getting up on my soapbox a little bit.
On the most recent one, our lawyer had to explain that the whole logic of having the clause in there, had to explain it to the arbitrator. And the arbitrator probably knew it, but it was good to go through the rationale.
Sure.
It's there so that the prices, they already saved the money. The owner saved the money of us not having to assume the worst case scenario of everything.
That's exactly
Running
right.
sands, obstructions.
Yeah. And also, I think, you mentioned in the last question, which, I asked, where it said, CPT data was not officially available, right? I think that is another problem. The client probably was, well, let's see, we may not have to share this data, and we may not have to think of the worst case scenario. It's not uncommon.
I don't think that one was intentional. It's just not their process. Somehow it was out there, but it wasn't listed in the bid documents. But the observation wells, it was probably just, they forgot they even had them. You hope that's the case, that they didn't intentionally withhold things.
Yeah, I hope so too. So what was the time period of this project from the start to finish?
We were probably installing piles for a year and a half or 2 years. I don't remember. It was in the mid 2000s. There was, I don't know, 400 or 500 piles on the job, something like that. Till it got closed out, it's probably another 6 or 8 years. It was ridiculous how long it took to finally settle.
That's very interesting.
Tom, I know you're a thinker, a student. When you reflect on this, were there any other lessons you learned from this project?
Well, yeah. So the large casing wasn't a problem drilling. The problem was getting all the cuttings back out of the hole. And, doesn't sound that bad. 12 3/4 OD casing with 11 3/4 ID. And we use 8 5/8 drill rods. So it's only, the endless is only something like that. But when you look at the flow rate it takes to lift the sand out of there, and that calculation is called uphold velocity. You take the flow rate and divide it by the cross-sectional area of the annulus, and that gives you a velocity that it's how much energy, how much water flow is trying to float the particles out of the hole. And we were shocked to learn that the 170 gallons a minute we were using as a flow rate wasn't enough to lift all the cuttings. We knew the cuttings were down there, but it took a lot more water flow to get it out than that 170.
So let me see if I understand this. So at the time, the mid 2000s, probably the largest casings are like 9 5/8 inch OD up until that point that you've had success with?
We had done seismic casings on other jobs of similar size, but we weren't using that to go the whole way down to the pile. So on this job, the casings went down and made a 12 3/4 inch pile, and then came back and stayed at the top. On the other, and doing that, then that's when you have to really get the hole clean. On the other application, we were just getting the casing in and then drilling a smaller pile through it.
And so, when you say you pick the flow rate of 170 gallons per minute, that's what your pumps, your standard pumps were able.
Yeah.
Okay.
So on a 9 5/8 pipe with 5-inch rods, it was enough uphold velocity to lift the cuttings.
So that's a lesson to learn that everybody can appreciate. It is that, hey, look, you have one process that's tried and true. You change one thing, in this case, your diameter, and suddenly all that tried and true stuff isn't necessarily applicable, and some unforeseen things could come up. What was your solution? Did you end up having to come up with a different clean out method, or did you get larger pumps?
Well, one of the solutions is to stroke the hole at the bottom. So if you can pull the rods up and go down faster, just the volume of, you can create a very high flow rate by pushing the rods down fast.
Because you're displacing quickly the water around it, and it
correct.
Gotcha. Shoots out
and
the top.
The other thing we did was over drilled and let the cuttings don't try to get over drill the hole, and the bar sits in it and sinks into it, but you still get the full length of a ground.
Isn't it kind of weird that we do brain surgery, but getting soil out of a hole is a struggle for us still? I mean, we do that. I don't know. It's the same thing with drilled shafts. Clean bottom.
Yeah, this wasn't about getting end bearing. This was just about getting the stuff out of the hole. So that.
Sure. I was just referring to the fact that here we are in the 2022, and we're still scratching our heads with the greatest minds in geotechnical engineering on how to remove soil from a hole, whether it's a micropile or a drilled shaft. I hope our listeners have caught on that Tom is an engineer's engineer. He loves finding solutions. While no project may be perfect, there are details in setting it up that can help us all. Joint ventures can be sticky, especially when problems arise. Hence Tom's comment about having 10 folks in a meeting when something is going wrong with the testing. Trying something new can lead to unexpected consequences, such as going to the larger casing can make it difficult for the pump to move enough water to raise the cuttings out of the hole. We want to thank Tom, and Tom, it's been a pleasure talking with you and being in your shoes for a day, and especially one that was through a challenging project.
Thank you, Tom. I think I've always seen you from afar, and in the last few years, I've started, having conversations with you and, getting to know you. So I think it's a very true pleasure for me to be able to be part of this podcast. And we have entitled the name of this episode as Beware of the Water. Cannot be anything else. It has to be Beware of the Water. And your team took a chance. You joint ventured. You tried a new micropile casing size, and you took on a riskier project for the health of the company. After all this, do you have any regrets?
Well, I wish I would have dug into the CPT data beforehand. The CPT, the squiggly lines of tip resistance and stuff, they don't help me much for micropile bond stress design. But if I dug into it further and looked at these dissipation tests, then I could have had a better idea of how much risk we were really taking with how much artesian pressure there was. I learned that joint ventures are frustrating. There have been other ones that went much better. And overall, the benefit of the joint venture was that the loss was shared, and it wasn't all on Nicholson. I regret that I couldn't convince the DOT to behave differently. This wasn't the first time we had the Boulder story was the same owner. And I couldn't make them think reasonably or fairly. I'd like to say thank you for inviting me. It's a privilege.
It was great. Thank you.
Thank you.
Lucky, this episode concludes our first series, Interview with a Survivor.
It's a wrap, Tim. Thank you all for watching this series. We are working on some new ideas and topics for you and plan to return with more common ground later in the year. You don't want to miss it. Thanks for your time and keep on surviving.
On behalf of DFI, we hope you enjoyed this episode. The views, information, and opinions expressed during Deep Foundation Institute's podcasts are solely those of the individuals involved and do not necessarily represent those of DFI. DFI does not verify or take responsibility for the accuracy of the information contained, nor does it warrant that the information contained herein is suitable for any general or specific use. The podcast is available for private, non-commercial use only. Editing, modification, or redistribution of this podcast is prohibited. Proudly brought to you by our series sponsor, Peer Research, and today's episode sponsor, Ishbek USA. Thanks for your time. Keep on surviving.